What if Earth missed the sun? Just once. Not exploded. Not struck. Just slightly off course. Right now, at this very second, Earth is moving 67,000 miles per hour around the sun. And yet, you feel nothing. No wind. No motion. No sense that we are racing through space. Because orbit feels permanent. Stable. Untouchable. But orbit is not a track in space. It is a balance. A delicate agreement between gravity and motion. If that balance breaks, even slightly, Earth does not simply drift. Everything begins to change. Temperatures shift. Seasons collapse. Oceans respond. The sky itself transforms. And the most surprising part? It would not happen instantly. It would unfold. Step by step. And by the end of the story, you will know exactly how long humanity would have, what would freeze first, and whether Earth could ever find another star. If you enjoy real, physics-based cosmic scenarios like this, you might find the rest of this journey fascinating. Because to understand what happens next, we first need to understand how fragile our orbit really is. Earth does not sit around the sun. It is constantly falling toward it. Gravity pulls inward. Motion carries us forward. When those two forces are perfectly balanced, we circle. Too slow, we fall inward. Too fast, we drift away. Right now, that balance is precise. But imagine something changes. No explosion. No dramatic event. Just one adjustment. Let's begin with the most extreme version. Earth suddenly stops moving sideways. In that instant, Earth would begin falling directly toward the sun. First, nothing feels different. Gravity on the surface remains the same. The sky remains blue. But astronomers would notice immediately. Earth is no longer orbiting. It is descending. And it would take about 65 days to reach the sun. But the transformation would begin long before that. As Earth falls closer, solar radiation increases. Temperatures rise. Not instantly, gradually. Ice sheets begin melting. Oceans absorb heat. Weather patterns intensify. But here's what changes everything. As oceans warm, more water evaporates. Water vapor traps heat. That trapped heat accelerates warming. This is called a runaway greenhouse effect. It happened on Venus billions of years ago. And if Earth continued inward, the same physics would apply. Clouds thicken. Skies brighten. Oceans begin to evaporate. Within weeks of reaching Venus-like distance, surface conditions become extreme. But that is only one path. Because Earth could also leave the sun in the opposite direction. And that story is colder. Far colder. Now imagine Earth speeds up. Just enough to escape the sun's gravity. Instead of falling inward, Earth moves outward. First, nothing dramatic happens. The sun still rises, but it appears slightly smaller. Each day, sunlight weakens. Within weeks, global temperatures begin to fall. Plants struggle as photosynthesis declines. Within months, growing seasons fail. Within a year, average global temperatures plunge below freezing. Oceans begin forming ice at the surface. But oceans are deep. They store enormous amounts of heat. Even without sunlight, Earth would not freeze solid immediately. It could take thousands of years for the deepest oceans to freeze entirely. And here is the remarkable part. Life would not vanish overnight. Deep beneath the oceans, hydrothermal vents already support ecosystems without sunlight. Microbial life deep underground could survive for millions of years. Human survival would depend on preparation. Geothermal energy, nuclear power, underground habitats. Civilization would shrink inward. The surface becomes an ice-covered world drifting through interstellar space. But what if the change were even more dramatic? What if the sun itself disappeared? If the sun vanished instantly, would we notice right away? Surprisingly, no. Light takes 8 minutes to travel from the sun to Earth. Gravity also travels at the speed of light. So for 8 minutes and 20 seconds, nothing changes. The sun shines, birds fly, waves roll. Then, at the exact same moment the light goes dark, Earth stops feeling the sun's gravity. Because Earth is already moving sideways at orbital speed, it does not stop. Continues in a straight line. This is Newton's first law of motion. No orbit, no curve, just forward. Temperatures begin falling almost immediately. Within days, freezing spreads across the globe. Within months, surface ecosystems collapse. But again, the story is not instant extinction. Earth contains internal heat generated by radioactive decay in its core. That geothermal energy continues. Beneath thick ice, oceans could remain liquid for thousands, perhaps millions of years. Life retreats inward, but the surface world becomes silent. And this raises a profound question. Could Earth ever find another star? If Earth drifts away, it becomes what astronomers call a rogue planet. We have detected such planets, wandering alone between stars. They are not rare. They are simply difficult to see. The space between stars is vast. The nearest star system is over 4 light-years away. That is roughly 25 trillion miles. For Earth to be captured by another star, the alignment would need to be nearly perfect. Speed, angle, distance. Possible? Yes. Likely? Extremely small. Most rogue planets drift for billions of years. Cold on the surface, potentially warm deep below. A world preserved in ice. But here is the reassuring truth. None of this is expected to happen. Earth's orbit is extraordinarily stable. The Sun contains 99.8% of the solar system's mass. Its gravitational influence dominates. Planetary interactions cause only minor long-term variations. For Earth to leave orbit, something extraordinary would need to occur. A close stellar flyby, a massive gravitational disturbance. Events that happen on billion-year timescales. Not human timescales. Not civilization timescales. Billions. Our orbit has remained stable for over 4 billion years. Long before humans existed. Long before complex life evolved. And it is expected to remain stable for billions more. Which makes one thing clear. The real story is not how easily we could lose our orbit. It is how precisely balanced it already is. Earth is moving at 67,000 miles per hour around the Sun. At 1,000 miles per hour at the equator. At over 500,000 miles per hour around the Milky Way. And yet, feels still. But that stillness is an illusion. It is motion in perfect balance. If Earth left its orbit, the transformation would not be instant chaos. It would be physics unfolding. Heat or cold. Evaporation or freezing. Drifting or falling. Each possibility reveals something extraordinary. Life exists because gravity and motion are perfectly tuned. Not too slow. Not too fast. Just right. If you enjoy exploring real cosmic possibilities grounded in science, subscribing helps support more documentaries like this. Because the universe does not need exaggeration to be astonishing. It only needs perspective. Right now, Earth remains exactly where it needs to be. Still circling. Still balanced. Still home. And perhaps the most remarkable question is not what happens if Earth leaves its orbit, but how rare it is that it hasn't. If Earth ever became a rogue planet drifting between stars, would humanity focus on surviving underground, or attempt to build ships to find a new sun?